All right, so for today we're doing section 4.6. Yesterday we did 4.5 where you guys had to do difference of two squares and grouping. Today we're doing solving quadratic equations by factoring. So we do have to know how to factor. Okay, that's one of the main things that we've kind of been going over, so factoring. And I want to remind you of a property from Algebra 1, or I guess we can call it Math 1, which basically is called the zero product property. Okay, and it says if you have two things that are being multiplied together, so right there you can see if A times B, right? Two things that are multiplied together and they equal to 0, then either one of those things or the other thing or both are equal to 0, right? Because if you have two numbers and I tell you that their answer is 0, then one of the numbers has to be 0, or maybe they're both equal to 0, right? It could be 5 times 0 or 0 times 10, right? Or 0 times 0, okay? So that's what this property basically says. If two things are being multiplied and they equal to 0, then one of them is equal to 0, or the other one is equal to 0, or they're both equal to 0. So we're going to go with the both of them idea. The meaning is, or the reasoning is basically this. If I have two things, let's say something like this, that are multiplied and they're equal to 0. So x plus 1 times x minus 2 equal to 0. That's two things that are multiplied and they're equal to 0. Then you can say that either x plus 1 is equal to 0 or x minus 2 is equal to 0. And you can solve for both of them, right? This would be x equals to negative 1 and x equals to 2. So you can solve. But the thing that's important is I have to factor in order to have them as two pieces that are multiplied. Okay? So once I factor them and they look like this, x plus 1, x minus 2, something like that, then I can break them apart and solve individually. Okay? Because of the zero product property. So our job today is to factor appropriately so that we can get them into factored form, two parts, and making and then setting them equal to 0 so we can solve. So that's our job for today. Now, some of your homework will be nice and easy for you guys. This kind of looks like the one I just wrote, only a little different. But some of the homework is going to be nice and easy. It's going to be pre-factored for you, okay? Then some of the homework you're going to have to factor, all right? So this is pre-factored for us. It says solve each equation by factoring. Notice it's already factored. Okay, they have x minus 2 times x plus 1 equals to 0. Right? So all I have to do is note that two things are multiplied and they're set equal to 0. So according to the definition from Math 1, I can write x minus 2 is equal to 0. X plus 1 is equal to 0. So if I add 2 over to this side, if I move it over, I get x is equal to 2, and the other one I'll subtract 1. I get x is equal to negative 1, and here are my answers. Since it's two different numbers, I'm going to write it out as a set notation, okay? So here's my solution. And that's it. It's not harder than that, okay? When it's pre-factored for you, you just got to basically set it up and set them equal to 0, solve each one, and you're done, okay? But that's if it's already factored. So I'll show you another one. But once it's already factored for you, you don't really have to do too much work. Just break them apart and set them equal to 0. So here's another one. Okay, v times v plus 5 equal to 0. Okay, so v times v plus 5, that's equal to 0. So notice, it's v times v plus 5, something times something, right? A times b, the way the formula says, right? So since it's two things being multiplied and they're set equal to 0, then what you can do is set one of those things equal to 0 or the other one of those things and set that equal to 0. So v equals 0, v plus 5 equals 0. Now, v equals 0 is already solved. I don't have to do anything to that. That's done. The v plus 5 equal to 0, I'm going to move it over. So that gives me v equal to negative 5. And I'm done. So I'm going to write my two answers, negative 5 and 0. And that's it. So again, pretty easy. Once it's done for you, no big deal. Okay, one more of these that's already pre-done. Okay. So this is the quantity of 2x plus 3 squared equal to 0. How do we get rid of a square? A square root. Yeah, we're going to take a square root. Okay? So I'm going to get the quantity of 2x plus 3 squared equal to 0, but I'm going to take the square root of it. That's how we get rid of a square. So that power of 2 disappears, and we get 2x plus 3. And the square root of 0, well, that's 0. And now I just got to solve that little piece, and I'm done. So I'll subtract 3, right? I'll move it over to the right side, so I get 2x equals to negative 3. And then if I divide both sides by 2, I'll have my answer. And this will be just one answer because it's not solving two different parts. So x is equal to negative 3 halves. And I'm done. So again, some of your homework, probably about half of it, I'm assuming. As I look through it right now, yeah, half of your homework, the front side, the whole front side is like this. It's all pre-factored for you. All you have to do is solve it. That's going to be done for you. Now, the harder part is when it's not done for you. Okay? So when it's not finished, you have to do it. So this one is one that we have to factor. So we're about to practice this again, right? We did factoring of r squared plus 4r minus 5 using the x method. We did that on Thursday before you guys had the day off on Friday. So we're going to have to do that again. Okay, we're going to have to factor r squared plus 4r minus 5. So let me remind you, my a term is here, b term is here, my c term is there. Okay, so a is 1, I'll just write it down, b is 4, c is negative 5. Again, these are not things you have to do. I'm just doing it to kind of help us so when we do this process, we kind of know where we're getting the numbers from. Remember, you're supposed to do the x method whenever you have a trinomial, right? 3 terms. Remember, the power should be a power of 2, a power of 1, a power of none. In other words, r squared, for r to the first, and then there's no r on that 5, right? So power of 2, power of 1, power of none. That's how you know you're going to be doing your x method. So on the top of the x, you're supposed to multiply a times c, right? A times c. So a times c is negative 5 because it's 1 times negative 5. On the bottom, you're supposed to put your b value. That's a 4. Okay? So now you got to think of two numbers that multiply to negative 5 that add up to a positive 4. 5 and a negative 1. Yeah, that's a good choice. 5 and a negative 1. Because 5 times negative 1 is negative 5. 5 minus 1 is 4, so that's good. Then you're supposed to divide by a. But will anything happen if I divide by 1? No. So then I just skip that step. So here we go. These are my options. So I'm going to write r plus 5, r minus 1 equals to 0. Remember, the plus 5 and the minus 1 that I wrote come from those two circles, right? And the r is used because that's the letter that I'm dealing with, r values. So notice, now it's r plus 5 times r minus 1 equals 0. So that basically is that property, right? Like you have something times something equals 0. So what I'm going to do is I'm going to separate them, and I'm going to solve them individually. Okay? So r plus 5 equals to 0. R minus 1 equals to 0. Solve both of them and you're done. So I'll move the 5 over. That gives me r equal to negative 5. I'll move this 1 over. That gives me r equal to 1. So my two answers are negative 5 and 1. The work is not supposed to be that difficult because you're supposed to be good at factoring already, right? Like I told you, factoring is something you learn near the end of middle school. You did it during 9th grade, during 10th grade, right? It's not something that ever goes away. Heck, you'll do it in calculus if you ever happen to take that. You'll do it in higher level math than calculus. It never goes away. So they're assuming you've got the practice. This isn't supposed to be the hard part, right? The new thing is just setting it equal to 0 and then solving. Okay? So hopefully you're not struggling with that, but there you go. We found our 2 answers, and we're done. Now, this is something you guys did yesterday. Okay, this is called a difference of 2 squares. So notice this does not have 3 terms, so I can't use the x method, right? There's a b squared, yeah, but there's no b to the first. If there was a b to the first, then I could probably use the x method. But I have 2 terms. So what you do when you have 2 terms is first you check to see if they have a common value, right? A common number or a common letter, but they don't, other than 1. You can take out a 1 from both of them, but that gets us nowhere. But you can't divide everything by 2 or by 4 or nothing like that. So then what you're supposed to notice is it's 2 terms, okay? There's a minus in the middle, so there's a difference. And each one of those terms I can write as something squared. I can write 25 as 5 squared. The 4b squared, well, I can write 4 as 2 squared, and I can write b squared as just a b that gets squared. So 2b squared is 4b squared. 25 is just 5 squared. Okay, now I'm going to set that equal to 0. Now yesterday in the lesson you learned that if you can, let me just rewrite it here just in case you didn't see it. But it basically said, if you can write it like this, something squared minus something squared, then automatically this is what you do. A minus b, a plus b. That's what you do. It's just like a habit, right? A quick reflex. If I can write it as something squared minus something squared, then I can write it a minus b, a plus b. That's called the difference of 2 squared. That means that I can write what I just put here as 2b minus 5, 2b plus 5, right? A minus b, a plus b. My a term is 2b. My b term is 5. So 2b minus 5, 2b plus 5. And then I solve them both. So here we go. 2b minus 5 equals 0. Now yesterday you didn't do any solving. You just did factoring of a difference of 2 squares. So that's what we just did. We just factored a difference of 2 squares. Remember, it's called the difference of 2 squares because it's a difference, there's a minus, and both terms can be written as squares. So a difference of 2 squares. Okay? Now if I solve the left side, I get 2b is equal to 5, and I'll divide both sides by 2. So b is equal to 5 halves. I'll do the same with the other side. I'll move that 5 over, so I get 2b equals to negative 5. And if I divide everything by 2, I get that b is negative 5 halves. So my 2 answers are negative 5 halves and a positive 5 halves, right? So let me write that down right here. B is negative 5 over 2 and a positive 5 over 2. If you want to put plus or minus 5 over 2, that's fine. But I'm just going to leave it as 2 separate answers. Factoring a difference of 2 squares is supposed to be easy once you figured out that it's a difference of 2 squares. Okay? The hard part is noticing that it's a difference of 2 squares. Again, how do I know it's a difference of 2 squares? Well, first give away 2 terms. So once I know it has 2 terms, it has a possibility of a difference of 2 squares. Then I see that it's subtracting, so it's a difference. And then I have to make sure that my 2 terms can be factored, not factored, they can be rewritten as something squared. So right here I noticed like 4b squared is just 2b squared, and then 25 is just 5 squared. As soon as I did that, I knew I could factor it using a difference of 2 squares, and that was good. Okay, so I think we have one last one, and that's it. And this one is actually going to be an x method. It doesn't look like it right now, but remember, we have to make sure everything is set equal to 0. For solving, everything should be equal to 0. So I'm going to get this 13n, and I'm going to move it over to the left side. Okay? So I'll move it to that side. So this is going to look like this. 5n squared minus 13n plus 8 is equal to 0. Notice I have a power of 2, right, n squared, a power of 1, that's n to the first, and a power of none, meaning the last number doesn't have a variable, right? So a power of 2, a power of 1, a power of none, that means x method, okay? Now, my a term is 5, my b term is negative 13, and my c term is 8. Now remember, this one's a little bit more tricky because my a term is not a 1, so I do have to divide. It's going to make some changes, so we'll see. Let's go ahead and start this off. A times c, that's 5 times 8, that's 40. Okay, and then on the bottom is negative 13. So two numbers that multiply to 40 that add up to negative 13. Negative 5 and negative 8, yeah. Negative 5 and negative 8. Now I'm supposed to divide by a, which is not a 1, so now it does matter. So if I divide by 5, this becomes negative 1. And if I divide the other one by 5, well, 8 divided by 5 doesn't work, so I'm just going to circle it. Okay, those are my two factors. So let me write it down. I have the letters n, right? So n minus 1, n minus 8/5 equals to 0. Now, according to definition, you can't have a fraction, right? So I got to get this 5 and move it over here. So it's going to be n minus 1, 5n minus 8 equals 0. And from there, solve, and you're done. Okay? So n minus 1 equals 0. 5n minus 8 equals 0. So just solve both of them, and you're finished. So we'll add a 1 here. So n is equal to 1. For this one, we'll add an 8. So 5n is equal to 8. And then divide by 5. And then right now, I want to address something really quick. So I got two answers. Now, sometimes people will tell me, I noticed you got the answer of 8/5, and I noticed in that factor, if I just would have left it n minus 8/5 and set it equal to 0, I would have gotten my answer immediately. Could I just do that? Yes. Okay? When you're solving, you can leave your factors in fraction form because you're going to solve for them anyway. So your answers are most likely going to end up as a fraction. So when you're solving, you didn't necessarily have to write this out, okay, when you're solving. If the instruction just said factor, then you better get it to 5n minus 8. But if it's like solve it, and you're going to solve equal to 0 stuff, you don't have to rewrite it if you don't want to. It might save you some steps, okay? But if you want to do it anyway, that's fine. But you don't have to change it to where there's no fractions, okay? Only when solving, though. If it just said factor, then it better say n minus 1, 5n minus 8. But if you're solving, you can go to the previous step and just solve from there. Okay, that's up to you. So this is what your homework is for today. So let me go ahead and stop this video. If you guys have any questions on yesterday's homework, maybe you want me to do a homework problem for you, I can do that. Okay.